and welcome to Math with Asna. In this lesson, we'll discuss why AAA and SSA are not valid for triangle congruence. We are going to talk about why these don't work using a coordinate grid. Let's start with AAA. Why doesn't AAA work for triangle congruence? So AAA is referring to the angles. It's if three angles are congruent to the three angles of the other triangle. Why doesn't that work? Why can't I use that to prove that triangles are congruent? That's because if you have two triangles such that their angles are congruent, it is possible to have triangles with different lengths. I'm going to draw it out and you'll see what I'm talking about. So let's draw out another triangle that has the same angle measures but different lengths. I'm going to start off by extending this line here. Okay. And I'm going to extend this line. There we go. And I did this such that these two are congruent and these two are congruent. But so far, this angle measure is not changed. It's still the same. I'm going to connect these two. And it just so happens that this third side, right here, and this third side, these are parallel. Well, if these are parallel, then I know that these are corresponding angles, so they're congruent. I also know that these are corresponding angles, so they're also congruent. So I have two triangles, the green and the black, that I've shown have the same angle measures, but they're clearly not the same triangle. These triangles are actually what we call similar. They're similar triangles. And that is a lesson for the future. For now, we're talking about triangle congruence, and it's just important for you to know that AAA is not going to work for triangle congruence. We also have SSA, and yes, it is very intentionally written in that order. Why doesn't SSA work for triangle congruence? Let's say you've got a triangle, and these are your SSA, two sides and the non-included angle. Can I make another triangle that has the same congruent sides and angle, but it's not the same triangle? And I can actually do it pretty simply. What I want you guys to do is imagine that I'm going to take this side here and I'm going to shift it. I'm going to rotate it like this. So notice I'm not changing the length here, right? I'm just rotating it. And I'm going to move it over here. So I'm going to keep rotating it so that it is touching that side and it's touching the vertex. There we go. This here is the same length as this side. These two are the same length. And I just showed that because I didn't change the length to move it here. I just rotated it and kind of rearranged it. If you wanted to get even more particular about it, you could use these right triangles and you could find the length and actually calculate it, and you would find that they're congruent. So I have two triangles. I've got this one right here, the outer one, and I have this one right here. They are clearly not the same triangle. It's obvious that they're not congruent because I'm on a coordinate grid here, so it matches up. This is not congruent to this, but it does match SSA. I do have two sides congruent, another side congruent, and the non-included angle congruent, but they're not congruent triangles. When you're trying to show why something is not true, you need a counterexample. So SSA and AAA don't work for triangle congruence because I could find an instance where they fail. And that's the key thing here. If you are trying to use something for triangle congruence, SSS for example, it has to work for every single triangle. If you can find even one instance where it does not work, then immediately you would say that's not a valid theorem. So these are your counterexamples. This is why SSA and AAA don't work for triangle congruence. If you learned something, please like and subscribe, and stay tuned for more videos.